Welcome to all our attendees. I can see that the number of people coming in, the numbers are increasing very quickly. We'll start at about 3 o'clock. Hello, Mr. Bay. I see you are here already. Hello, Mr. Pam. Hi, Tan Sri. Thank you for being with us. Good afternoon, everyone. I hope you can hear me. Once again, we have great pleasure to welcome you back to the Malaysian Water Association and Malaysia International Water Convention webinar series. Today is our 6th webinar in this series. We hope you are all well and keeping your spirits high. Here in Malaysia, many of us have already returned to work in the office. How about you? Let us know how is it like working from home. Well, today we have with us Dr. Ramakrishna from Singapore, who will be presenting to us on important but neglected aspects of water treatment plant life cycle. Dr. Rama has more than 10 years of experience in consulting and research work on wastewater engineering. He is currently the manager for water services in Tussud. Thank you, Dr. Rama, for your time to present at our webinar today, and we appreciate you taking time to prepare for today's session. So halfway through the webinar, today we'll do our poll again. So do participate by voting and answering 3 short questions. And if you have any questions for Dr. Rama, the Q&A icon is located at the bottom of your screen. So if you move your mouse, you see a Q&A icon. So you can just click onto the icon and key in your question. This webinar is also available on YouTube when we are finished. So you can just like and follow us on our Malaysia International Water Convention Facebook page, and all the details and links will be posted there. So before we start the presentation by Dr. Rama, let's hear from our webinar host, Yang Bahagia Datuk Engineer Abdul Kadir bin Muhammad Din, President of the Malaysian Water Association. Dr. Kadir?
Okay, thank you. Dennis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi and good afternoon. So ladies and gentlemen, here we are again at the 6th series of the webinar that been jointly organized with ProTem. And I would say that this afternoon presentation is also very important, quite similar to what you have last week on the law of construction, but this one is about project management. So the project management of the water asset And the title is very interesting. As you can see, is important but neglected aspect of water treatment plant life cycle. So focus on the asset itself. So I hope you'll be benefiting from this webinar seminar on this subject matter, because it has yet to be explored on a long-term basis. And this, hopefully, this will be a starting point looking at the asset per se. So I'm sure all of you are aware that every project has certain phases of development, be it small or big. It can be in years or it can be in months. So, but the clear understanding of this phases flow allows us, all the decision makers, senior managers, engineers, and the supervision staff to maintain control of the project more efficiently. To an outsider or layman, it might seem like project management process is very easy. It's just like talking to the clients, scheduling of meetings, managing the work itself by assigning staff the task to relevant respected staff, and also following up with the deadlines by using all the proper tools. But anyone who has managed a project, and the government and water industry had implemented several mega and complex water supply and storage project, well, we will tell you that it's more than that. That is why the project lifecycle approach is so useful, because it will determine the future direction of how and to choose the best of everything in a project. So there is a certain project lifecycle for every project, program or product, which there are particular phases of development. This requires a lifecycle approach to establish their management strategies. Hence, when we are clear on and understand what these phases are, it will give us a better control over total corporate resources in accomplishing the desired objective. You have to understand what is the project is all about, and at the end of the day, what is the return. So the phases of development are referred as life cycle phases. It's very important to realize that the project life cycle for each project may differ in both the number of phases it may have and the detail within each of these phases. So if you look at basically the concept of phases comprise conceptual. So the project start from the beginning, the initiation part. We have to initiate what is this project is all about, and then we look at the conceptual. After we have talked about the conceptual, then come the planning stage, how the strategy of plan. Then you go to detail planning. When you talk about detail planning, this is where you ascertain the value of projects, and then it will look at the choice of material. If a treatment plant, they will also assess the treatment plant processes, what is best to be used for that particular project, because there are a lot of factors need to be considered, and this is where it will determine the life cycle of the project itself. So I'm sure the presenter, Dr. Rama, has very vast experience. They will share on the project life cycle and the different phases in his presentation afterwards. So the focus will be on three important aspects, i.e. the feasibility study, membrane autopsy, then a desalination plant and water efficiency, to highlight the importance in WTP water treatment plant life cycle. And this is the aspect of experience that Dr. Rama will share with us, and hopefully we will benefit from this and apply in our engineering practices. Ladies and gentlemen, the challenges in Malaysia water supply sector are the poor efficiency and the effectiveness of the water supply system, and the inadequacy of funding. That is the most important part of the water sector. So following the objective of the 11 Nation Plan to improve public assets, it is our view that a feature of the project life cycle, i.e. the life cycle cost, or in short is LCC, should be applied in critical infrastructure such as the water industry. I would like to touch briefly on the LCC in my address. We are aware that much of water, wastewater, and stormwater infrastructure has been traditionally costed from either a capital or operating cost point of view. However, the calculation of the full cost of the infrastructure associated with the provision of water services over the full life cycle provides a fairer basis for the comparison of traditional and alternative approaches to water supply and disposal. So life cycle costs, or LCC, involve combining the estimated capital, maintenance, operation, and a replacement cost over the whole life of an infrastructure facility into a single value, which takes into account expenditure occurring at different stages in the life of the infrastructure. So from the business perspective, it is of critical importance that the long-term management of our water assets or infrastructures is in a cost-effective manner as mentioned above. Asset management considers capital, operations, maintenance, repair, renewal, replacement as investment decision. It is an accepted fact that proper asset management is capable to allocate capital and operational expenditure to achieve short-term value and long-term sustainability. So today, life cycle costs had been introduced in the Malaysian construction industry and practiced by the JKR or the Public Works Department, and we hope it will be picking up in the water industry. To keep abreast of what's happening on the life cycle cost, the CIDB, Construction Industry Development Board, has established its own subsidiary company to look at the life cycle cost of construction industry. And with the hope that one day it will also include water sectors, and then it will pave the way for the water sectors to apply this LCC in all our works. So very briefly, LCC model includes the costs of all impacts, both directly and indirectly controllable by water authorities, i.e., the coverage of the cost should be extended to those impacts resulting from water systems implementation that are not included in the water operators' responsibilities or budgets, such as local authority and environmental requirement. At the same time, the impact of technology and the system change and its effect on the level of service provided needs to be assessed. This is necessary as water authorities become more focused on the cost effectiveness of their system and allows selection of the highest quality system and the lowest cost. LCC plays a critical part as this decision needs to be made based on total life cycle cost implication. Finally, I take this opportunity to thank TUSUD, Malaysia Sdn Bhd, an institutional member of MWA, for coming forward to share their experience in this afternoon, and also to Protect Group for hosting this webinar. MWA is a strong proponent for collaboration between the government and stakeholders and the private sector in developing frameworks and encouraging sustainable practices within the water sector or industry. So in MWA also hopes that this collaboration today will assist water industry practitioners in preparation of implementing the project lifecycle and the lifecycle costing approach for more resilient services for the betterment of our industry. Last not least, in the new normal, this will be continued until such time, and I think we have to adapt to the current situation of the whole world global, that we will have this similar seminar in the future to keep abreast with what's happening and to share knowledge with all our members, and we welcome those who want to present and also to become our members and benefit from being a member of MWA. So with that, I thank you and hope you enjoy today's seminar and it's a fruitful one. Thank you very much. Good afternoon.
Thank you, Dato. So now, without further ado, I would like to ask Dr. Ramakrishna from TUSUD to begin his presentation. Dr. Rama, are you ready?
Yes, Dennis.
Okay.
Okay. Thanks, Dennis, for the introduction. Thanks, Datuk, for the kind words. Okay. So myself, Ramakrishna. So I'm working in TUSUD. I'm in charge of the water services. We are providing consultancy services for all aspects of water life cycle, as Datuk mentioned, starting from feasibility study until the refurbishment. So most of you might know TUSUD as a service provider in terms of certification, auditing, and inspection services. We do provide consultancy services in industrial sectors, especially energy services, conventional power, renewable energy, and environmental sectors. So we do have offices in most of the countries, and we do have more than 25,500 employees. And we do have different services in all aspects of consultancies. So as part of sustainable service portfolio, we do provide consultancy services in water, energy, renewable energy, and environmental. So as you can see here, we do provide start from due diligence, detailed project management or bonus engineers, and membrane services, plant auditing, and water footprint and efficiency certification. So we do provide consultancy services from start to end of the water life cycle. So before going into the topic, I just want to introduce typical water treatment processes that are currently gaining popularity. So one of them is desalination. So desalination is purifying the water from sea. So as you can see in the picture on the left side, we take the water from the sea and we treat it. We call it as a pre-treatment, where we get rid of the salts and particles, and then we treat with the typical RO systems. Currently, people are employing RO system, but previously it used to be thermal systems, either distillation or thermal technologies. Then once the water is purified, it is being post-treated because the water is so pure, you cannot have any minerals in it. So they need to remineralize it and also kill all the bacteria using UV disinfectant or some other chemicals. So finally, it will be supplied to the client or the community. So another one is the wastewater treatment system, where we take the municipal wastewater or industrial wastewater and get rid of the particles and debris using different screens. And in the primary clarifier, we try to get rid of all the suspended solids that is very heavy, so that is it can be settleable. Then we send it to the next stage of purification, where they reduce the organics by using biological treatments. And after that, it will be passed to the next stage of treatment if you want to remove the nutrients like nitrogen removal or phosphorus removal. Finally, disinfection and remineralization, and it can be either discharged or it can be used for recycling. And another treatment process that we generally come across is industrial wastewater. So the industrial wastewater is actually customized and specific to the particular industry. So the process and technologies they use is depending upon the industry and the sector. So that's why I didn't mention here, but these are the two typical large water treatment plants that we come across. So the reason I mentioned here is people who don't have knowledge on water treatment and the typical process, they should be understanding what is the starting to the end. Start from the intake in both the things, treat the water, and then to either discharge or send it to the community. So what are the typical life cycle stages involved in the wastewater? So you can see that any plant, any construction project, whether it is a power plant or water plant or any other big project, that involves typically these stages, where it starts with the feasibility, then followed by planning, procurement and construction, then commissioning and testing. Then once the plant is operated, so there are different various other services that we can provide or need a third-party consultant to look after the plant whenever there is a problem in the plant. And once the plant has achieved its life cycle, once the plant is running for so many years, there may be a need for refurbishment. So actually there are, each section, there are multiple aspects that we need to engage a third-party consultant. So these are the different phases where a developer or a owner of the plant will engage a third-party consultant in order to safeguard the stakeholders' interest. So today, in today's seminar or today's talk, I'm not going to touch on each and every aspect because of few reasons. Number one, the time is not sufficient to cover each and every aspect of the life cycle. Second thing is, some of these aspects like procurement, project management, testing and commissioning, these are pretty much standard in most of the construction projects, whether it is a power plants or wastewater recycling or desalination. So today my focus will be on three aspects, which is feasibility study. Second will be membrane service. Third will be water efficiency advisory. So why I choose these three? Again, the title of the seminar is important but neglected aspects. So these things seems to be very trivial or not really paid much attention, but they actually add a lot of value. So as a should, we always look at add value to the customer, add value to the project, add value to the society. So we want to highlight some of these services where a third-party consultant can add value to the overall project, so that it will, in terms of smooth operation, in terms of achieving more efficient project, we want to highlight these three services. So I'll go first with the feasibility study, then membrane services, followed by the water efficiency advisory. So again, in any plant, why we doing the feasibility study? Actually, the feasibility study is, we can call it in a different terms. Some people call it as a technical due diligence, environmental impact study, or social impact studies. So there are many ways people do it, but I call it as a feasibility study. So why should we do a feasibility study for any project? Because you can see there are some questions, we need to find answers to these questions asked by different people. Questions asked by the government, asked by the public, asked by the investors, asked by the developer, asked by the operator. So we need to understand, we need to establish a ground questions there so that everybody understand the purpose of the project and what's the benefits, what's the advantages and disadvantages. All these things can already answered in the initial stages of the project, that is in the feasibility study. So if you go to some of these questions, you can see how can I secure the access of the feed water, or what happens after my discharge of wastewater. So where should I discharge after treating the water? So, or is this technology is good, or should I apply different technology? Or because of my plant or because of my construction, is there any impact on the environment, impact on the society, or impact on any of the ecology or the public or society, even the economic impact or economic benefits of this? So I kind of categorize this feasibility study into two aspects. One is technical due diligence, another one is environmental and social impact assessment. So technical due diligence is only considering about the project and asset itself, and also the technology and process that is being used in these water treatment plants. So it really review the project efficiency and also competitiveness of the technology and competitiveness of the process, and where should be the location and what should be the capacity, and all those aspects will be covered in technical due diligence. So in environmental and social impact assessment, so how this is going to impact the environment, or how it is going to impact the economic and social life of the neighborhood, and also the nearby environment in terms of water, air, soil, all kinds of environments. So to predict and assess, why should we do the whole job of this feasibility study? Because if we do a poor job in this phase, the whole project can be land into big problems. The project has to be stopped because it doesn't comply with certain regulations, or it is impacting the environment so much that it has to be stopped. So there's a big loss if you don't do the feasibility study properly. So maybe before going into the actual examples and more discussion, I just want to I want to take all the participants a poll and try to understand what do you think about this feasibility study? Yeah. So the question is, which of the factors have significant impact on the operation of a desalination plant? Let's consider you are looking to have a desalination plant. All the participants, please answer your response, and we'll see the response in a minute. But consider that you want to think of a new desalination plant, and which of the factors are more important? I know everything is important, but in your perspective, is it the technology that is used in the process, or proper operation and maintenance, or environment? Which one is the most impactful factor that will affect your operation of a desalination plant?
Can we click more than one, Dr. Rama?
Yes, we can.
Okay. Okay, I think that's enough. And I think we can put down the question. Okay.
Yeah. Okay. So, okay, I expected this, but again, that's a good thing. 62% of the people think that the technology used in the process will affect the operational desalination plant. As I mentioned earlier, there's no wrong answer, but if you think in realistically, let's say once you start the desalination plant, you install it, you commission it, and you start operating it. Then you realize that the technology that you adopted is not good. You still can change it, or you still can do something to avoid the huge amount of losses. Or if your operation is something go wrong, or if you have something trouble in operating the plant, still we can look into it and then we can rectify it. But I would suggest, if you don't do proper assessment of environment, the environmental effects cannot be not in our control. So that may lead into a big problems. So let me take a couple of examples to try to highlight the importance of the environmental impact studies or feasibility studies. So this is one of the desalination plant in Africa, North Africa. And as you can see in the picture, the desalination plant has very near to the sea. And this desalination plant has a lot of problems. After 2 years of operation, they experience a lot of problems. Then we go and try to understand what's the problem. Then we realize that in this particular region, there are heavy rains. The winter, the rains are almost like every week. Because of these heavy rains, there's a lot of mud and particles are being discharged into the sea, near to the intake of the desalination plant. So you can see how heavily the rain can happen. So all this water can be discharged into the sea. As you can see in the middle picture, a lot of plant debris, everything will be taken into the sea, which is exactly the point of intake. So if you take a lot of water from here, and the system, the design, and the pretreatment, and also all the technology are not designed to accept these things. So the environmental impact study or the feasibility study, they should be considering all the environmental factors as well. How long the rain will be there, and what is the change in the temperature, and they have to consider the environment of 1 year or more than 1 year in some cases to consider all these in variations. Then you have to design the plan, and you have to select the suitable technology, and then you have to operate it accordingly. And also you need to optimize operations so that you can avoid this environmental impact. So eventually this plant cannot be operated at all. So they have to completely redesign the process and then establish the new pretreatment systems. And then it incurred a lot of cost. All this because they did a very poor job during the feasibility studies. So that is one example. Again, this is not in our control. Sometimes the factor is not in our control, but you have to plan it such a way that it might happen, because the previous 10 years of data shows that there's a lot of rains, there's a lot of particles may go into this area. So they have to design accordingly. So this is the second example. There is a desalination plant in Middle East. As you know that in the right picture, you can see that more than 70% of the desalination plants are situated in Middle East. So what happens is, this desalination plant, you don't need to worry about the whole process. You just need to consider they're taking a seawater and they're using the RO to treat the water, and the brine of the RO they're discharging into the sea. So what's happening is they're taking around 50,000 ppm of seawater and they're discharging around 69 ppm. Ideally, they're supposed to discharge 100,000 ppm, so double the concentration of the salt. So typically what happens in a desalination plant is, you take the seawater, you concentrate it, that means you are doubling the salt concentration and you are discharging into the sea. Again, you need to take the same water from the same sea. So what happens is, eventually the salinity of the seawater keep increasing. So when the seawater salinity keep increasing, the actual process and the technology that you designed cannot handle the high salinity. So you have to change the whole system, or you need to have additional treatment systems after every few years, because the seawater salinity keep increasing and it will impact after every certain years. It may be every 2 years or every 5 years. You need to look into your process. You need to change the whole thing. Instead of that, if you do a feasibility study and you already know this, that the seawater salinity is keep increasing, so you will be planning your system design such a way that even with the increase in salinity, you can actually operate very smoothly without any disturbance or without any interruption in your plant. So because of increasing salinity, there will be any other additional effect like membrane scalings, and you can't produce the permeate with low salinity and all those things. So there's many effects are there. And again, I just put this an example to say that some of the factors are not in our control, but a proper feasibility study or techno-economic study will highlight these risks so that we can improve the design or we can improve the operation and management. I hope everybody understands the importance of feasibility study. I know most people who do the feasibility study just for the sake of compliance, just to get the funding from the banks, or it's a requirement for the contract, water purchasing agreement. But the reality is you have to engage a third-party consultant and you have to do a thorough study of all the aspects. Then only you can highlight the risk involved in it. So it will avoid a lot of cost in the future. Okay, so moving on to the next aspect, membrane services, membrane autopsy, which is a very simple thing in the whole life cycle, but very effective. An effective way to increase your operational performance and reduce the life cycle cost. So as you can see, as you can hear from different people, that use of the membrane becomes inevitable. So everybody uses membranes, one or the other part. So what happens is, once you start using the membrane, you'll have a problem with the membrane filtration. So these are some of the problems that you encounter. You need to replace the membrane more often, or your permeate quality is deteriorating, or you need to clean so often to keep it running, or the downtime is very high. So these are the typical problems that you can hear from either desalination plant or wastewater treatment plant. Any water treatment plant that uses the membrane will have these problems one or the other time. So before further going into the membrane, I just want to ask again the other poll question to all the listeners, and tell me, what is your opinion? Is there any way I can avoid the membrane fouling, or the problems comes with the membrane fouling? So once you start filtrating, membrane get the fouling. So how to avoid the membrane fouling? How to avoid this issue? Either chemical dosing, or frequent cleaning, or frequent backwash. There may be many other options, but generally, typically, these three are the one that people use it. And now we are going to discuss in more detail about this membrane fouling and how to avoid and what to do with membrane fouling in coming slides. But I just want to get your opinion on how to avoid a membrane fouling. Okay, once we have sufficient response, we can see how.
Can we see the results, Sandy?
Yeah. Okay. So again, first of all, none of the answers is correct. You cannot avoid fouling, first thing. But how to manage the fouling? Maybe I should ask, but again, I just want to make sure you guys is a little bit interested. So you cannot avoid the membrane fouling, because you are pushing the water against the membrane, and eventually the things will accumulate on the membrane surface. So the scaling and fouling is inevitable. But of course, you can manage it by all these three: chemical dosing, frequent cleaning, and frequent backwash. It's good. It's surprising that frequent backwash is highest people responded, but actually in reality that is a trick that every operator uses, or is actually more effective, and most of the plant operator use it as a trick. It is not in SOP, or it will not be there in a lot of standard procedures, but frequent backwash is something that helps membrane to have less fouling or reduce the scaling. Thank you for the response. So once the membranes, so let's talk about the membranes and membrane foulings. So as you can see, adoption of the membranes is not only in desalination plants or wastewater treatment plants. Any industry that requires water for its processing, they are using the membranes or they're adopting the membranes in their process to get the fresh water, to recycle their wastewater, or to meet their discharge regulations. One or the other way, all the industries, almost all the industries are using the membranes for their water treatment. So the adoption of the membranes is become very popular. So what are the different types of membranes people are typically using? As you can see, actually the water contains different pollutants, starting from particles, clay, bacteria, salts, even the ions. Of course, salts is composed of ions. So not a single membrane can filter everything. That's too much for a single membrane. So people will deploy different membranes, use for different application. As you can see, each membrane can remove certain kinds of pollutants. So MF can remove only the particles and other things that is greater than 0.1 micron. UF can remove some of the particles, bacteria and other viruses. NF and RO, most of the ions and very small particles it can remove. So people use different membranes for different purposes. So once they start using the membranes, as you can see in the right hand picture, you are pushing the water against the membrane surface. So most of the pollutants will be accumulating on the surface of the membrane, forming as a cake layer or a thin layer of these pollutants. So if it is only ions, we call it as a scaling. If it is organics, we call it as a fouling. If it is only like particles, we call it as a colloidal fouling. In any case, all these things are inevitable, as I mentioned earlier, and everybody will face this problem of membrane fouling and scaling. So what happens if membrane get fouled? Yeah, I buy the membrane, I start operating it, and then my membrane got fouled. So I still keep operating using these fouled membranes. So definitely your production will reduce, your energy consumption will reduce because it is blocking your pores. You have to push the water with high pressure. So you have to replace your membranes. So your replacement frequency will increase. So all of these things will result into low yield. You're producing less amount of water than designed. And you have to incur a lot of cost, either in cleaning or in replacing membranes or paying penalties for not able to produce the sufficient water. And again, if the operator and the developer, if the off-taker, they are all in an agreement, sometimes you may land into the legal risk as well. So as I mentioned earlier, in the life cycle of the whole water treatment plant, membrane autopsy is not at all a big issue. But again, it will land into a big problem. Membrane fouling is a big issue. But if you can solve this issue or if you can manage it very nicely, it can save a lot of cost. So if you want to find out what is causing the membrane fouling or who is the culprit, it can be anything. It can be a feed water characteristics. So the feed water that you are taking, it might have a different composition or the composition changes because of the rains or sudden change in the temperature, or it's the membrane characteristics because the membrane that you're using and the feed water, they are not of good match, or they are not suitable membrane that you're using. Sometimes that could be the issue with the chemistry. And operational conditions. Most of the cases, operating parameters are most of the times the reason for these membrane foulings, because there is something wrong with your feed water, you are going to foul it. So you should use operational techniques or operational tricks to avoid this fouling. But most of the times the operators just follow the SOPs and then they just follow the same condition even there is a changes in the feed water or changes in the environmental conditions. So eventually it will lead into the membrane fouling. So If you want to avoid the membrane fouling, what you should do, you should find out out of all these factors, which is the culprit. Once you found out the culprit, you try to solve it. So how to find out the culprit, or how to find out the reason for the fouling, is membrane autopsy. So as a third-party independent consultant, we do membrane autopsy services. Because we are not a membrane suppliers, or typically what happens is, in any plant, if you have a problem with the membrane, you generally go to the membrane supplier who provided the membrane or who sold the membrane to the plant. They generally take the membrane and then look at, and then they try to find out, okay, you need to change the operation or you need to change the chemical regime, which might be true, but getting a third-party opinion will give you the real cause, and also can actually find out the problems. If they have real problems with the membrane itself, the membrane is not suitable or membrane is of poor quality, this is not a suitable application for this kind of membranes. So I just want to touch upon membrane autopsy and what exactly the information that you can learn from this membrane autopsy. So that will help you to understand or to improve the plant operation. So typically we get the membrane from the plants, fouled membranes. We do these services. We do exterior inspection, interior inspection, and we cut the membrane pieces. And we also collect the membranes or the foulant or the scaling from the membrane surface. And we do extensive analytical analysis. We have a ISO certified labs. So we take all these membranes and the foulant to the labs, and we analyze each and every aspect of the physical and chemical parameters of these membranes and foulants. And from those analysis, we try to correlate, or we try to establish the reason for the fouling. So I just want to show how typical membrane autopsy takes place. So once the membrane comes, it should be preserved properly and then send it to the labs. And then once we receive the membrane, we open it up, we look into the exterior parts. And then what happens in the exterior part? Basically, we look at for the debris, we look at for the damage, we look at everything is in the original condition or is there any change. So as you can see that based on our observations, we try to correlate with the possible causes and we give the recommendation. So for example, if there is a cracks, so the cracks can only happen either during the transportation or during the loading of the membrane or unloading of the membrane. So you should be really careful. So we can recommend that the operator should be very careful. So if some debris is found on the outside of the membrane, then we can say that the pre-treatment is not working. So that's how the pre-treatment allowed certain particles and debris into the membrane. So once the exterior inspection is done, we try to do the interior inspection. So we cut the membrane, we open up the membrane, and we look into each and every leaf of the membrane, and also the spacers. So we try to collect all the information. We look at the qualitatively, we take the pictures, we find out all the abnormalities that is present in the membrane and the spacer. And again, we try to correlate what could be the reason, what could be the cause, and what could be the potential recommendation, how to avoid this fouling or scaling. So as you can see, if there is a salt observed on it, or if there is a organic fouling is there, then we can say that you need to add antiscalants or use biocides to avoid the biological growth in the membranes. And then we can do some analytical tests to look at the membrane integrity. So we take the membrane samples and we do dye test and Fujiwara test. These tests typically tell us whether the membrane has any pores or membrane is damaged or membrane is oxidized because of the chemicals that people are using during the operation. And then we take the foulant and then send it for different analytical tests. Again, don't worry if you don't understand all the analytical techniques. I'm a chemistry background, so I like talk about these things. But again, as an operator, as a developer, you don't need to understand how the techniques are done, but the value is what information you get from this analytical test and how it will helpful for a smooth plant operation. So again, FTIR generally gives the peaks or the functional groups present in that foulant. So those functional groups can be correlated into what kind of foulant it is, whether it is a biological origin or whether it is a metal oxides or is it is because of the salts. So that will help us to recommend that which chemical to use, what kind of cleaning frequency you should do. These kind of things can be recommended based on this information. And we do SEMEDX. SEMEDX is will give you actually how the foulant look like, visual observation up to the nanometer level. We can find out whether it is what kind of micro it is, what kind of bacteria it is, what kind of scaling it is, whether it is organic fouling or bacterial fouling. Again, EDS will give you elemental composition or a chemical composition of the particular foulant that will help us to find out exactly which salt it is, whether it is a calcium carbonate, calcium chloride, or is it a iron oxide, is it iron coming from the feed water. So those kind of information can be analyzed from this technique, and that will help us to recommend suitable action. XPS, X-ray Photoelectron Spectroscopy, again, this is advanced analytical technique that actually go very deep into the chemical structure, and you can even find out the bonds between each thing, so that you can establish very accurately the chemical formula and the chemical compound present on the membrane surface. Again, don't worry about all these chemical formulas, but what we're trying to say is by using the XPS, you can actually find out what compound and what functional groups are present in it. From there, we can identify the reason for the cause, fouling and scaling. Another very simple but very informative test is weight loss. So basically what we do is we collect the foulant and then we dry it. So we find out whether is a moisture loss. After the moisture, we burn it at 550 degrees. So generally at 550 degrees, all the organics will be burnt out. The left out will be either clay, silt, or is metal oxides. So from this composition, we can find out how much is from the organics or how much is from inorganics. That will help us who is the key culprit. Is it the fouling is happening because of the organics, biological thing, or is it from the inorganics present in the water? Some other analytical tests. This is specifically for the microbiological thing. So every water, or of course, microbiological thing will be there in almost every stages of the water treatment. But how much is there? So CFU per meter square is the quantity that we measure in terms of the presence of microbiological things. Is it too much, too less, or the presence of biological thing on the membrane implies that there is organics are there. Organics in the water is acting as a food for the microbiological thing. So that's why they are growing there. So that means either we need to use a biocide, which can kill these antibacterial things or immobilize them or deactivate them, or you need to focus on treating the organics in the pre-treatment. So that way you can avoid the membrane fouling. So we do all the analytical tests and we collect all the information and then we put it into a report. So this report is not just the summary of all the analytical tests. So this report is basically the analysis of the results and try to correlate the chemical compound and the structure and type of the foulant that you have, and also the recommendation, how you can avoid it, how you can manage it, and how you can add the value. So we try to add the value to the customer by our recommendation. But these recommendations will improve the plant performance very significantly. So you can see some of the things that you can see in the table that what are the different recommendations that we do and how the customer can benefit. Our recommendation could be use different chemical or do some different suitable anti-scalants to avoid the fouling and scaling, or you need to do the pre-treatment properly to avoid the membranes, because typically a desalination plant or wastewater plant, there will be thousands of membranes in big plants. So understanding the reason for the fouling and doing a proper action can save millions of dollars. So that's why membrane autopsy is a key, should be the key aspect during the plant operation. And I just want to give a couple of case studies, or maybe one of the case studies that we do for a desalination plant in Middle East. It's a very big desalination plant, and their plant efficiency gone down, and then they can't operate, they can't produce sufficient water. So they send the water membrane to us, and then we open the membrane and we do all kinds of analysis, and we found out that there is a a lot of fouling is because of the organics. So we asked them to change the chemical cleaning. Of course, every plant has their own SOP, what chemicals to use, how to clean. The membrane supplier will give a standard SOP of using the chemicals. But again, based on your feed characteristics, based on the changes in the operations, you need to be understanding what exactly to use and how to use. So that we can tailor as a third-party independent consultant. We can actually tailor cleaning cycles and cleaning mechanisms, or also the pre-treatment action that you need to take to improve your plant operation. Okay, that's about the membrane autopsy. And the third one is water efficiency. Again, nowadays these water efficiency studies become very popular because everybody want to show that we are using less water, or we are water positive. It's not something that's a luxury thing. Now it becomes a necessity that when there is no fresh water available in the vicinity, the only way you can generate the fresh water is by recycling your own waste. So Singapore is a typical example where we are trying to get more than 50 or 70% of our water by waste recycling. So it is because of water scarcity, every country or every company is forced to think about the water recycling. So they're discharging a lot of waste. So now there is no term called waste. Now the waste becomes a value. So everybody is saying it as a value recovery. So there is no more wastewater treatment. It's like value recovery, or how to utilize it more efficiently. So what exactly this is? We identify so basically you need to identify whether you can recycle the water from your discharge, or is there any other water stream in your whole process or in your plan that can be recycled. So all these things will depend on few factors. What is the water quality? What is the water usage you have? Within the plant, you can use the recycled water for different purposes, washing, cleaning, or some other process where you don't need very high quality water. Of course, we can generate the drinking water even from the waste. That may involve a lot of process and technology. But very simply, if you want to improve your water recycling or reduce your fresh water intake, you have to do this water efficiency studies. So typically, we do these kind of studies. You can call it as a water audit, water footprint calculation, or advisory on water efficiency, but all of them will mean the same thing, which is reduce the water wastage, increase the water recovery. So what typically we do as part of these studies, we identify the water loss, we identify the water streams that can be recyclable, we identify the quality of the water that you can get it, and so that you can use that wastewater stream as a sustainable water source, and you can reduce the discharge volume and increase the water efficiency. So I put a typical process diagram just to highlight that how we can do. Typically, any industry will take the feed water either from the fresh water from the municipality or surface water, and then they use the water. And after they reuse the water, they will just discharge most of the times, or they regenerate the water, and then the regenerated water can be used again into their operation. So that's a typical. I don't need to explain this one again. I just want to take again another poll question for the audience to understand what you think of why we should do this water recycling, or what is the important aspect, or what are the important advantage by doing this water recycling. So is it to reduce the freshwater intake, or is it to reduce the discharge, or is it a sustainable water supply? Which one you think that is more important when you are thinking about water efficiency? Once you have the response, please show the results. Okay, that's great. I really like it because reducing the discharge or reducing freshwater intake would not really benefit significantly. Looking it as a sustainable water supply, because you always have waste. So when there is a waste, you always produce the wastewater. So if you can recycle the water from that stream, it is a sustainable water supply. So so that means everybody know how valuable to look into this study. Most of the times they don't value this, or they don't look it as a big issue. You know, water is a water life cycle, but I believe that this is something is important aspect as well. I just want to close it by giving an example of what we did for one of the study. So this cement company actually use a lot of water, and then they actually claim it as water neutral or water positive, which is good, for environment, which is good for themselves, so that they reduce in water intake cost and they reduce cost on water discharge. So we go there and then look into the whole process, look into their water balance and all their water streams and how they're utilizing the wastewater. And we actually encourage all the companies to do this. And also we actually provide advisory services, how to achieve water efficiency, how you can improve your water recycling, those aspects. So we did this, and then we certify that this is really water positive. So I think that's all from my side. Again, I could not cover all the aspects in water life cycle because it's too big, and I hope to cover in other session. But as a tutor, we want to add value, or we want to add value in terms of knowledge, in terms of understanding how a simple things also can improve your plant efficiency or make the plant in a smooth operation. So thank you, everyone. Thank you for attending. I know there's a lot of webinars and everything. Thank you for taking the time, and I hope you are safe and have a positive thinking.
Thank you, Dr. Rama. So, ladies and gentlemen, it's now our Q&A time. So right now we have two questions for Dr. Rama. Can you see the questions, Dr. Rama?
Yes, I can see. Do you have any? Okay, let me read the question first, then I'll answer.
Yes, and for the participants, for our attendees today, you can go to the icon at the bottom of your screen, Q&A. Just key in your questions there. Thank you.
Yeah. So the first question is, do you have any take or comments on the increasing popular use of ceramic membrane? Okay. So we are not a membrane suppliers, and as you can see, the talk is not about technology, or we are not promoting any company or anything. Yes, use of ceramic membrane become very popular, and because of tough to treat water, specifically chemical industry waste or very complex industrial wastewater, they're using ceramic membranes. Second question is, hi, Dr. Rama. I have one question. Beside membrane fouling, what are the other main problems associated with the desalination process that might involve big capex item for maintenance? If you do a proper feasibility study and assess all the risks that can come across, and if you have a good design and best technology, I think membrane fouling is the biggest headache in the operation. In O&M operation, you will not incur a lot of big capex. Membranes is the big capex, and chemicals is the second opex. Energy is the other opex. So membranes means fouling is the biggest problem. I hope I answered that question. How long does it take to do water feasibility study? Not water feasibility study, a feasibility study, the project feasibility. So depending upon the extent or the scope that we involving in that feasibility, if it involves environmental, social impact, technical feasibility, it would take a couple of months, because we need to analyze the data for even sometimes even 10 years. So how many people are living and how many things are doing. So just an example that the desalination plant that I mentioned, actually once the plant operation started, people start complaining that there's a lot of noise. So in the feasibility study, that should be covered. If there is a noise, what should be done and how to avoid it. and what are the actions that we should take when somebody complains like that. So I think depending on the scope, but typically it will take few months. What is the OPEX cost of seawater membrane water treatment plant? Very general question, but again, we can't say number. But if you say that in Singapore context, what is the OPEX cost? OPEX cost is very huge because energy cost is the highest, and because energy cost in Singapore is very high. So it depends on region to region, location, and your feed water quality, and also technology. So I can't say a direct answer for the OPEX cost of seawater membrane. It varies a lot, and it depends on many factors. Should the membrane autopsy be done frequently, or is it done only after encountering a problem? No. I will tell you, this is very nice question, because why we should do membrane autopsy? Only when you have a problem with membrane falling, then only you should do? No. If you do that one, that means you already have the problem. You already lost a lot of, means you already have the problem. To solve the problem, you're spending money. Before that, if you can send the membrane once in a few years, once in 2 years, once in 6 months, I know that which is going to be a problem, where you should take care of it, or is it a feed water quality, or is it treatment thing you need to take care of it. Then you can avoid the fouling, you can avoid all the cost. And also, we have clients where they send the new membranes, they send the fresh membrane to do the autopsy, and make sure the warranty that the membrane technology provider is providing, or the claims that they do, is actually true or not. That we can check. We can actually test the membranes in our labs and real water scenario, and we can find out the rejection, performance, and everything. That is one case. Second case, regular membrane autopsy will help you to identify the real problems, and timely action will save a lot of cost. How long is the usual or average service life of the membranes? Where would be the duration be dependent? Turbidity, TSS, cleaning frequency. Definitely on the feed water and the cleaning frequency. So the feed water, if the feed water quality change very frequently, then your membrane life typically comes down. Typical wastewater treatment after the MBR, it could be like 5 years. Membrane suppliers will give you a warranty of 10 years generally. But depending on cleaning frequencies and the feed water, every 2 years, sometimes you need to change if it is very bad quality. If it is a good quality and your operation is good, your O&M will actually impact a lot on membrane life. It can go anywhere from 2 to 10 years. How long will it take to inspect a membrane? Okay, once we receive the membrane in our lab, typically 2 to 3 weeks, we try to complete it. 2 weeks is a minimum time that we take. Can the membrane problem be solved without damaging the membrane through non-destructive way? Very good question. A typical plant will have 1,000 membranes. Sacrificing one membrane will give you more information than saving the cost of one membrane. You can find out the problems only by looking at water qualities and pressure drop. By you looking at operational parameters, you can estimate, you can identify certain problems, but membrane autopsy will give you a clear picture of what is exactly the reason. So we have newly built plant. How long do we need to operate our membranes before we subject them to the following analysis? As I mentioned earlier, once you already encountered the problem, it is too late. So sending the membranes once in 6 months, once in a year will actually save a lot of cost. But again, once you have the problem, it will be typically 1 year to 2 years. I think within 2 years, you will definitely have a problem with the membrane. That's what our experiences says. What is the best method to treat high COD? Again, a very general question. There's a lot of methods and a lot of technologies are available, either MBR, or biological treatment, or many advanced oxidation processes. But I think it is not a suitable forum to answer that question. It's a pure and technical question. In membrane operations and maintenance, is it advisable to mix medium fouled membranes with new ones or collect all medium fold membranes and mix new with light fold membranes. This is a typical tactics people use once the membrane fold. Once people understand that something wrong with the membranes, they try to replace half of the membranes. They try to replace with the new membranes partly and start operating it. Again, you can do that. That with very technical knowledge and with an expert advice, how much to change, how much percentage of the new membranes need to be replaced, or is it really good to replace all those things. One, you have to do the membrane autopsy. You need to understand the extent of fouling and the reason for fouling. Then only you can actually decide whether you need to replace the 100% or partly. Oh, I have a few more things. For plants that are operational, do you think there is a need for owners to hire third parties such as to double check on the operation of the plant and see if the plant is operating as per recommended procedures? Definitely. So as a third party consultant, we provide all the services that I mentioned in life cycle of a water plant. Plant auditing, plant inspection, and what is a forensic analysis of the whole plant is recommended once in a while. We have a clients who in Middle East who engage us as a third-party consultant to provide a plant inspection and full audit report. That means membrane autopsy, water analysis, and process checking the design review, process optimization, O&M review. So all these things will help you to improve your plant or identify the risk first. Identify which is going to fail, what are the gaps, or what are the things that you can improve in your operation. So as a third party independent consultant, we will help you to give you the impartial advice because we are not a promoter of any membranes or we are not promoter of any chemicals. So you will get an unbiased opinion from us. How cost effective is to use internet things to detect fouling and operation? Okay. Nowadays it becomes very popular. How to use the Internet of Things to detect the fouling? This is the question. And now there are people who are developing these sensors, and they put the sensors in the membrane modules, and by using different techniques, is increasing the resistance of the membrane or increasing the thickness of the membrane or impedance. You can find out your membrane is going to foul in next 6 months. So this is something in the water industry very actively people are trying to develop, and this is very hot topic. And that really helps. Actually, it has a lot of value. Instead of waiting for the membrane to fall, you can predict that next 6 months your membrane is going to fall. So then how I should act, whether I should do more frequent backwashing or use the chemicals to treat. So that's really advanced techniques that are coming up. How to measure the hardness? How to measure? You have a handheld meters. You have a nowadays portable spectrophotometers that comes where you can use on-site. You can send for the lab. There are various ways to measure hardness. When feasibility study not done or skipped, can't it still be done at later stage? For example, after membrane autopsy and results? Yeah, very nice question. Generally, the feasibility studies, we call it as then technical due diligence. It's no more feasibility study. Feasibility study is before even you do anything. That means whether it is feasible or not, whether you can do or not. Technical due diligence study is something like plant audit, plant inspection, and understanding what's the problem going on in the plant. Again, very good point that you bring out here is generally once the plant is installed, it runs for 5-10 years. Then now they realize that there is some problem. Or for example, the example I mentioned has salinity increases. They can't discharge their RO brine into the sea. So what to do with the brine? So one of the client engaged us to find out what is the best economic and technical best way to dispose my RO brine. So we call it as a technical due diligence or feasibility study again. So the feasibility study, what we take out is we look into all technologies, including GLD, lime softening, reuse water from it, or how diluting with the seawater. We actually find out 5 different ways of dealing with this brine, and we come up with the cost, energy, practicability, and all other things. operational maintenance and everything. So we suggested these are the 5 different ways you can do, and this is the best option. So in those kind of scenarios, you can do the feasibility studies. So most of the times, desalination plants of age 5 years, more than 5 years, we can engage the third-party consultant to do these feasibility studies, and also so that you can get how to deal with your problems. Okay, there's another. How much does a membrane autopsy usually cost? Okay, we should not supposed to say it, but again, approximately 4,000 USD. But again, this membrane autopsy is not a standard one. You can customize it. You can reduce the number of tests. You can increase the number of tests. You can ask specific things. We can even simulate a real scenario of RO operation in the lab. We can find out which chemical is compatible with your membrane, which cleaning chemical can do a better job. All these things can be done. So it's all most customizable. So the cost depends upon number of tests and your what you want to find out from the membrane autopsy. What is the most membrane friendly coagulant? What would be the top recommendation? Again, it's more of technical thing. I know about the coagulants, but there's a lot of coagulants available. It's purely depend on what is the composition of your feed water and what is your application. Are you going to coagulate in the primary before primary clarifier or secondary clarifier, or is it for a seawater desalination? So it all depends on the application and your feed water characteristics. By doing these two analyses, then only we can recommend which is the best coagulant. Again, we can provide such kind of services like which is the best membrane for this application, which is the best chemical for this application, or what membrane is good for the market for this application. So we call it as a best technology available right now for these suitable applications, or a desktop study of all GLD technologies. I'm just giving an example what other services we can do in terms of finding or supporting the owners and operators. Okay, I think I covered all the questions. Please feel free to ask any more other questions. Either in other, sorry, we didn't cover other aspects in terms of construction, owners engineering, and also there are many other things in the life cycle. But because of the time and also, as the title says, neglected but important aspects of the water cycle. So the construction, procurement, owners engineering is a typical services that any big project is involved, and the procedure is same and process is same. So we do provide all those services for desalination and wastewater treatment plants.
Okay, any more questions? I guess no more. So I think we can end today's session. Thank you so much, Dr. Rama, for presenting today's session. And I would also like to thank Dr. Kade and MWA for being the host. I believe Dato has already left, so he won't be making a closing address. So thank you everyone for being here. And many of you are regular attendees, so we really appreciate your passion for knowledge and support for our webinars. Now, next Tuesday, our topic will be rethinking customer operations for water utility. And our speaker will be Mr. Dylan Fernandez from Customer Solutions, Oracle Utilities. Mr. Fernandez will be joining us from Australia. So do follow us on our Malaysia International Water Convention Facebook page for all the details and the links. Thank you everyone for being here with us today. Once again, Dr. Rama, thank you for the time preparing today's presentation. And we hope to have everyone back again next week. Thank you very much and goodbye.
Goodbye. Thank you.
Bye. Bye everyone. See you next week.